consciousness, awareness, all these things are products of the brain. They're products of processing deeply the world around you. We think we have some grip on what some of the networks are in the human brain that are computing that kind of information that ultimately leads us to say, oh, I have conscious experience. So the question to me is, what systems have that kind of information processing? What systems build that kind of self-model? When you look at the very early stages of evolution, you're talking about bacteria. Some people would say, yes, they have consciousness. I think that's not correct. I think that's a mistake.
What makes you confident that bacteria don't have this rich self-model? Why would you be confident of that?
Well,
Dr. Michael Graziano is a neuroscientist and professor at Princeton whose theory of consciousness might just flip your brain inside out. He's the creator of Attention Schema Theory, the radical idea that consciousness is the brain's internal model of attention. No magic, no soul stuff, just a clever neural shortcut that lets your mind think it has a mind. Theory also explains why we think we have a hard problem of consciousness even though we likely don't, and has giant implications for AI. In this episode, we also strongly disagreed with each other about when consciousness first emerged, and it led to a very interesting back and forth. Remember to subscribe to the channel, it really helps us out. Otherwise, a future AI modeled on you will do it instead and take all of the credit.
The question of consciousness, in a sense, becomes the central question of our time. Right? Because AI is the biggest transition in human history, utterly transforming our immediate and deep future. At some point, we probably already are very close to it. AI that thinks it has a mind, thinks it has experience, claims it has experience. When you ask it, it will internally access its own models, and those models will return the answer that says, yep, you got experience. And so it will think it has a hard problem in the same way that we do, which is spooky.
Dr. Michael Graziano, for anyone unfamiliar with you or your work, what's the most important context for the listener to understand to get an idea for your life's work, your mission, what you're trying to achieve?
Well, I mean, I'm a neuroscientist. That's my main occupation, and certainly trying to understand how the brain works. I think lately the thing that I've been focused on is this question of the mechanistic basis of consciousness. And the reason why that, I think, has gotten much larger than just the questions of neuroscience is that it has connected to the world of AI, and our future with AI and with massively intelligent machines and the questions surrounding that. So suddenly this question of consciousness is much bigger. It's much bigger than any of the other scientific questions that I think I've touched on before. So that has been a major focus of my work lately.
Awesome. And we'll get into AI and consciousness later, because obviously, as you point out, it's such a big topic, and you now have AI leaders coming out like almost every week saying that their models are introspecting and they have awareness. Yes. And all of this, and we'll get to that, but I really want to start. Let's start really from the very start. So let's zoom back to the very first organisms, because you've written very beautifully in some of your books about how you think they started to gain an experience of what it is like to be that organism. So kind of paint that picture. I've been obsessed with this question for a while.
Right. So I've certainly written about this, yes, and thought deeply about it. A lot of people have. Part of the question is how you approach this topic of consciousness, experience, awareness, and so on. And I think different people have different philosophical takes on it. So not necessarily I'm going to take my particular approach to it. consciousness, awareness, all these things are products of the brain. They're products of processing deeply the world around you and building models or bundles of information that represent the world around you, but especially building self models, constantly refreshing models of your own internal processes, right? This is what consciousness is. This is to be aware of something, is to know that you are an agent that is deeply processing that thing out there. And so very simple organisms don't have any of that. In fact, even some very complex organisms don't have any of that, right? And so they can be reactive. They can be reactive in an incredibly complex way, but that doesn't mean that they have these rich self models. They don't know who they are. They don't know that they're seeing and processing the world. They have no conceptual level, and so I think when you look at the very early stages of evolution, you're talking about bacteria. Some people would say, yes, they have consciousness. I think that's not correct. I think that's a mistake that comes from, yes, I think there's a lot of what I would call more magical concepts of consciousness as a kind of essence that emerges out of biology. And then bacteria have the essence, the magic essence. I do not subscribe to this particular approach to the question. I think that's fundamentally mistaken. And then, of course, you have much more complex multicellular entities like sponges are technically animals. They do not have these mechanisms for building informational self models or models of the world. Some people point to plants. There's a whole world out there of people who would say plants are conscious, and not just, the more woo-woo side. There are people who would say, no, plants can process information this way and do that and make decisions and grow toward the light and so on and send signals via their roots. And that's actually all true. But it's not the same as building these rich conceptual models of the world outside of you and of yourself. So I think you have to get very far along the evolutionary scale before you start getting these rich models.
Interesting.
Yeah.
Yeah, it's been I think a couple of years ago, or even before starting the podcast, I would have fully agreed with everything that you said there. And I think guest by guest, I've been edging towards the more radical ideas of biology where consciousness is in very simple organisms and very simple systems. What makes you confident that bacteria don't have this rich self model? Why would you be confident of that?
Well, so again, it comes down to this very key question of what is your philosophical take on consciousness itself, right? What is that thing? And my approach has always been everything you know about yourself, no matter how certain you are of it, no matter how much you jump up and down and say, yes, this is true, I know it's true of me, derives from information in your brain. Otherwise, you can't think it, and you can't express it into words, and you can't know it at any kind of level, conceptual or otherwise. It's always information represented in your brain. And we know that representations in the brain are at the level of patterns of activity across networks, large networks. So when you say that thing is red, it's because representations in your brain express that information. When you say, I have a subjective experience, I feel, I know, I am, you say that because you think it. You think it because there is some kind of representation, probably automatic, probably continuous representation in your brain, building this information, building this self model. Without that, none of that exists with respect to you. Right. So when you look, just to give an example, if you take a person and if you could systematically damage one wouldn't want to do this, but if you could systematically damage all the the color processing networks. And this has actually happened in people. There are patients like this. Those people lose the ability to process color because their neural mechanisms that build that information set are gone. They don't process color, they don't see color, they don't experience color. Nothing, their color becomes irrelevant to them. Can't even remember color anymore. I mean, they remember that they had a thing that they called color, but that world of information becomes irrelevant to them because it's been stripped from the neural processing in their brain. And so, same with consciousness, with experience-ness. If the systems in the brain that process that information that tells you that you have it, if those systems are gone, it becomes irrelevant to you. You no longer have it. And so the question to me then, so that I take as the philosophical perspective on consciousness. And we think we have some grip on what some of the networks are in the brain, in the human brain, that are computing that kind of information that ultimately leads us to say, oh, I have conscious experience. So the question to me is, what systems have that kind of information processing? What systems build that kind of self-model? Now, I don't really know the answer to that. One can speculate, but looking across the evolutionary scale, what I see is that kind of model of me embedded in worlds, me processing worlds, that kind of self-model that tells me I have an experience of the world. I don't see that. I think it's unlikely that that exists in the vertebrate line before, I don't know, somewhere around the common ancestor of birds and mammals. I will put that relatively late, maybe 300 million years ago. If you came to me and showed me, no, look, this bacteria actually processes information, we know it does, processes it in a very complex way, we know it does, but it does it in such a complex way that it's actually building the same kind of intricate self-model. Like it is actually thinking to itself, there's a me and there's a world, and I'm experiencing the world because it's built that kind of self-model. If you could show me that, I would say, yeah, you're right. That thing has what we have. Thus far, I don't think that's the case. I seriously doubt that that's going on at the cell level. I think it's going on in really rich, large neural networks, probably in birds, mammals, and common ancestor. That would be my guess.
Interesting. That is not what I would have guessed from looking at your work. This is super interesting to me. I'm curious what experiment could be done where you would read it and then be like, oh, I was wrong. Bacteria are conscious. Like what exactly is sufficiently complex enough that the bacteria will do it, and then you'd be like, and then you ascribe it consciousness?
Well, again, think about the color example. I do not think bacteria see red because they lack the information processing for building that kind of model of the world.
Sure.
Like there's nothing in them that builds the construct of red. And mind you, red is a construct. There's no red out there in the real world. There's spectral reflections, and then our brains simplify that and build a kind of simple model of the world. And in that simple model, there's a thing called red, or a thing that we call red, but there's red and there's blue and there's green and yellow and brightness. And this is the simplified model our visual system constructs. So if the brain's not building that model, then it's not that thing doesn't see it. So I don't think bacteria have that, right? So yet we have a kind of a model in our brain somehow that says, I am a me, and I experience, and I have phenomenology. There's some kind of bundle of information constructed that's telling us that. Why would we have that? Why would we have this? Why would the brain describe itself that way? What is it trying to depict? Right? We know. I just gave you the example of color. We know red represents something in the real world in a kind of schematic way. but the brain is evidently building some kind of schematic model of its own internal processing. So one thing you would have to show is that bacteria do build self-models, build models of their own information processing, not just process information, but in effect tell itself, I am processing information, and build predictive models of its own information processing. Now if you do that, then we're getting somewhere. Then you can start asking, well, what are those models? What's the information content of those models? Are they similar to the information content of the models that people have? Probably not. But I mean, I'm not closed to the idea that other creatures have these kinds of internal models. So I'll give you an example. Bacteria, I think, is very, very, very unlikely to have these kinds of systems. Like brains took millions of years, billions of years actually, from the beginning of bacteria, billions of years to develop these neural systems, these brains that can process, really build models of the world out there in any kind of level of complexity, and build models of self in any level of complexity. And so I know that what I just described to you is it's a very vertebrate-centric view. But I am very intrigued about the possibility that other branches of life also evolved similar kinds of processing. And people often point to the octopus as a wonderful example of
what I was going to mention. Yeah.
Yes, exactly. It is very similar to humans in many ways. It has big eyes. It's a very visual creature. It's a visual hunter. It has really good visual attention, so it can focus on one thing or another thing, and discipline its own internal processes to focus on different things. So it must have predictive models and rich models of its own internal brain state so that it knows what it's doing and can control what its mind is doing. It wouldn't surprise me then that octopuses have self models. Yeah, but so
MindLab Pro is a scientifically backed nootropic designed to enhance memory and focus and keep you as mentally sharp as possible in 2026. And before you click off, it has been scientifically proven in not one, but 3 separate double-blind placebo-controlled trials that it really works. In one study, healthy adults took MindLab Pro for 30 days and improved on 3 separate information processing tasks. In another trial, adults improved on a set of memory tasks. The interesting part is in both trials, this improvement did not happen in the placebo group, which is a really strong piece of evidence that what is making the difference is in this bottle. MindLab Pro has no proprietary blends, complete transparency on ingredients, and has full third-party testing so you know exactly what's in the bottle. Performance Labs is one of the most scientifically rigorous supplement companies that exists, and that is the exact reason that I have decided to partner with them. I also take their sleep stack every single night, and they sell a bunch of other high quality supplements. They offer a 30-day money back guarantee, so there's literally zero risk in trying them out. You're supporting the giant shoulder by using the link in the description. Now back to the episode.
As for specific experiments, it's very hard to do that. One of the nice things about AI is that you actually can get in it and study in the black box and see what the information is and study the representations internal to it. The tools are not there yet to stick wires into a brain and say, that's the sum total of the information represented in that brain, right? So it's very hard. The technology, I think, is in principle possible. It's just very hard right now. It doesn't exist to go into a brain, take all that information and then translate it into English and say, this is what that brain is saying. The hypothetical speechinator that you plug into a brain and it translates it into English. So then you know what representations are in that brain. We don't have that for most of biology. Yeah.
I'm super interested to get a sense for where you draw the line in the sand then. If consciousness is sufficiently complex information models about yourself and your environment and the relationship between yourself and your environment. Like, what do you think is the most complex organism that doesn't quite have that? Like the way I've been thinking about these things, and how, this is very much along sort of Michael Levin's train of thought, and people like him, is that these are all continuums. They're all distributions, and the model is so completely, entirely different in a bacteria than it is for us. But I find it hard to say, right, up until this level of complexity models, it's not conscious, and then after it, suddenly it is. Like, that's sort of a stranger even to me than saying it's a distribution and they're all models the whole way down, but just in very differing levels. It's modeling different features, different levels of sophistication about the self and the environment and the relationship between them. So, like, where do you draw the stand, and like, how do you think about that in general?
Yeah, well, I think you're right. It's continuous. Sometimes I think of it a bit like tool use. It used to be people said people are the only tool users. That makes our species special. And of course, that turned out not to be the case. And not only that, but to some extent, bits of tool use can be seen all over the animal kingdom here and there. And people have pointed to, ants can use leaves in a way that is technically tool use and so on. So there's a continuum there. And then, of course, there's people who build tools like building spaceships, which are very, very complicated tools. So, of course, there's a continuum. So one of the problems I see is when you talk about information that represents the outside world, in other words, a model of the outside world, you can get very simple or very complex. And you can go all the way down to bacteria. You can go even simpler. Like people have talked about, well, a thermostat, in a sense, has a representation of the outside world at the simplest possible level. And yes, that's true. And you can talk about self models, that is information that represents or depicts or predicts the self. That too, you can get very, very simple all the way down or all the way up. So yes, you can think of a continuum there. When you talk about consciousness, I think we run into a problem, because there is a certain tendency to think of it as the magic feeling. And people want to know, where does the magic feeling emerge? And my answer would be, that is a mistaken approach. There's no magic feeling. The question is, which systems depict themselves as having a magic essence in them?
Right.
We think we're conscious. We believe it at a conceptual level because something deeper than the conceptual level is building that kind of self-model of ourselves. And so then we say, philosophers and so on, write down, oh my God, I have a magic essence inside of me. This is this thing that I'm going to call consciousness, the experiencedness in me. And what they're doing is accessing and drawing on some kind of self-model that's telling them they have this property. I don't think bacteria have that. I don't think it makes sense to talk about that. So I'll give, and I don't know where the line should be. I'm sure the line's fuzzy, right? It's sort of like, where's the line between amphibian and mammal? Like, there is a fuzzy line in there. Evolution has a fuzzy line in there. No fuzzy line. You're absolutely right. I'll give you this analogy that I often use of the body schema. So the brain also builds a model of the physical body, and we move around, and therefore, because we need to know where our limbs are, we keep track of what our limbs are, what their shape is, how they're moving, and how they can move, and predict how they're likely to move in the future. All this is called a body schema, and it's very, very important that we have a body schema. We know that because if you lose an arm, you'll get a phantom limb. And the phantom limb is the brain's model continuing to fire away and represent the missing limb. And so you could say, I have an arm schema, a hand schema. How far back in evolution can you go before you say animals or creatures no longer have a hand schema. Like, do bacteria have a hand schema? And the answer is, I mean, they probably have information about themselves, but they don't have a hand schema specifically. Like, that makes no sense. At some point, animals evolved forelimbs, and that's kind of like a hand. And I'm sure that they have schemas of their forelimbs, and so on. So it's a bit of a gradation and a slidey slope. But yeah,
Yeah.
I don't think it makes sense to go to the bacteria level or the plant level and talk about a hand schema. And so
Yeah.
I think consciousness is a really, really specific model of specific kinds of things in the brain that tells us specific things about ourselves. And it makes no sense to go all the way back to bacteria and say they have that. I mean, they have something that is conceptually akin to it, because I'm sure they have information about themselves. But that would be my answer there.
Maybe it's worth really defining what you think consciousness is, because I've been given out to by listeners because for having 2-hour conversations about consciousness where neither person defines consciousness.
Mhm.
And it can sort of result in you talking past each other a little bit as you just have different models of what that word
Yes.
means. So
Yes.
maybe it's worth defining that now.
Right. So let's start in layers. We'll start with the first layer, because a lot of people who approach this from outside the field think of consciousness as everything in my mind. You know, I'm conscious, I have self-awareness, and I know who I am, and I have a memory, and I can make decisions, you know, so I have autonomy, and I have free will, or however people conceive of it. I have agency and experience and this and that. And, you know, you go, I think probably one of the classic accounts would be James Joyce writing from the stream of consciousness perspective of one person with all the swirling stuff in the head. And that's how people used to think about consciousness. That was the psychological, like, I think William James began to coined the term stream of consciousness 100 years ago or more. But as time has gone on, some of these pieces have been chipped off from the question of consciousness, like memory. Well, there's a mechanism that stores information and they can bring it back up again. That's not really consciousness. You can be conscious of memories, but memory itself is not the consciousness mechanism.
Yes.
And you can be conscious of visual things around you, but vision is not itself the consciousness mechanism, and so on for decision making, and so on for this and that, and so on. And as these things have been chipped off, by the end of the 20th century, I think most scholars focused in on one question, the question of experience. That is, whatever it is you're doing, whatever it is you're processing, do you have a subjective experience of it or not?
Yeah.
And of course, most 99% of the stuff in our heads, the answer is no subjective experience of it. But there's this 1% of stuff that we say, oh my God, I'm conscious, I'm aware of that. So by now, I think most scholars then would start with that question. Consciousness is the experience-ness itself. So that's layer one. This is what we're talking about. Just to get the viewers on the same page.
For
Right.
sure. No disagreements there. 100% on board.
Okay. Now, the second layer, I would say, is we've run into a problem because almost all approaches to consciousness start with this. They say, I have a subjective experience that emerges. It's kind of like an adjunct to the processing in my brain. It isn't the processing, it's what it feels like. It's the feeling that goes along with it, the experience that goes along with it. The experience itself is not a physical thing. You can't weigh it. You can't put it in a vice and see how much poundage it takes before it breaks, and so on. I mean, you can't push on it and measure a reaction force. So the experience itself is not a physical thing, but it's somehow adjunct to physical processes in the brain. But how does a brain produce the non-physical experience? As soon as you ask that question, which is what 90% of scholars out there ask, I think you put yourself out of business. I think you have gone down the wrong path.
Right.
And I'll explain why. And I'll go back to an analogy that I was just using, the body schema, and in particular the phantom limb. So we know that, like I said, if you get an amputation, I hope that never happens to anybody out there, but if you get a missing limb, missing arm, you'll get a phantom. And the phantom means that you can close your eyes and say, oh my God, my arm's there. And you can tell people about it and say it's in this position, and it's cold, it's kind of warm, or it's itchy, or whatever. My fingers are wiggling. And so it's invisible, but you're reporting it. So what is the phantom? What is that phantom? And there's two classes of explanation, and both have been proposed in the past at some point, especially if you go back 100 or more years. Explanation one, the brain builds a model of the body called the body schema. That model is rich information, automatically constructed. You can't help it. It's always happening. It's continuous. It's deep down, underneath cognition, underneath language. It's building a model of your body, a bundle of information that depicts your body. That information can supply your higher cognition. And so you can know, in that sense, what your limbs are doing. And then your cognition can inform your speech, and you can talk about it. And that's why when you lose your arm, but the model is still there, building that representation, that information gets up into cognition. And so when someone asks you, close your eyes, tell me about that limb, you say, oh, wow, it's like it's still there.
Yeah.
Explanation one. Explanation two, no, let's take that model at face value. Let's assume there actually is a magic invisible arm growing out of my stump. And we don't know what it's made out of, but there it is. That's the explanation for the phantom limb. Okay. And now you can spin theories, wonderful theories. How does the invisible arm grow? What is it made out of? Is it made out of quantum mist? Is it made out of electromagnetic energy? Does it grow out of the stump because of integrated information in your stump makes the arm grow? And then after you've decided, no, this is the theory, or people argue this theory, that theory about what makes the ghost arm grow. But once you've decided on one theory, you're like, no, that's what makes a ghost arm appear. Now you have another problem. How on earth does that ghost arm, now that it's there and generated in space, invisible, how does it affect your brain in exactly the right way? How does it get into your cognitive networks and make this neuron fire more and that one fire less in exactly the right pattern, so that your cognitive networks know that the ghost arm is there, so that you can talk about it and say, oh yeah, it's there? Like, that is a mystery. They're all mysteries, one after the next after the next. So the magic arm hypothesis is fraught with problems. And here's what happens. The moment you say, I introspect, my cognition accesses deeper models, and they tell me things. The moment you say, I'm going to assume those models are literally accurate. Now let's explain how that happens physically. Then you're in trouble.
Right.
Because the model's not literally accurate. And that, I think, is what's happening with consciousness. So there is some kind of model being continuously automatically constructed underneath cognition. We can't help it. It's always there. It's informing our cognition, telling us that we have experienced this, that we experienced this, that we experienced that. And this is why we say we do. We say it because we believe it. We believe it cognitively because our cognition is accessing these deep automatic models. But if we take those models at face value, if we say, let's assume they're literally accurate, let's assume there literally is a non-physical essence of experience, how does it get physically produced? Now you're stuck because there's no answer, because that isn't the right question. It's like asking, how does the invisible magic arm grow out of a stump? The question instead that is answerable is, what is that model, and what's building it, and why? What's the adaptive advantage of the brain building that kind of self-model that tells us we have the magic inside of us? Why build that kind of self-model? And so all my work in consciousness has been on this question of what are the cognitive benefits? And I think there's many cognitive benefits of building simplified, somewhat inaccurate, but really useful models of self, right? And so this is where I diverge from many, many people who study consciousness. Not everybody. I mean, there's a vibrant group of people who are on the same wavelength as me. But therefore, the question for me becomes not how does the brain produce the magic essence of experience, but why and how does the brain build a self-model, bundles of information that tell us we have those things. Yeah. And so anyway, I think that's my roundabout summary of what consciousness is in the kind of work that I do.
Yeah. No, really well explained. I like the arm example. I think phantom limbs has always fascinated me. I remember reading about them in Oliver Sacks's book, a decade ago, and it just blowing my mind of what the hell, how the hell does that possibly exist? And started me on this train of science communication, because it's tragic and horrible for people who have to, of course, that live through that, but it's also just so richly interesting. It's so bizarrely strange.
Yes.
So on this journey of trying to figure out why it's useful for an organism to gain awareness of itself, what do you think are the best answers for that?
I think there's two crucial answers. One is organisms at some point develop attention. That's a very colloquial word. It's a difficult word, which is why I was kind of hesitating. So everyone knows what attention means colloquially, but what does it mean neuroscientifically? The brain builds representations of things. Some of those representations are going to be more important for you in the moment, and others are less important, and you can ignore them. And the more important ones get bigger signal strength. So if you're looking at a cluttered scene, but you're really hungry and there's a donut, the visual representation increases in signal strength. And that begins to dominate downstream systems. And then you're much more likely to react to it and process it deeply and know everything about where it is and who wants it and so on. So attention is the selective ability to enhance some representations in the brain over others. And we're doing it all the time. And it's the key to intelligence. Many people don't realize how crucially important attention is, because it's selective. And without it, we would need brains the size of a planet to process in equal measure everything around us.
Right.
But instead, with a relatively small 3-pound brain, we can be absolutely extraordinarily intelligent and focus in on one thing or a few things at a time and really deeply process them. And this is the power of attention. And to control attention, which we need to do to move it around almost as if it were another limb, another part of the body. We need to move our attention from thought to thought, from object to object, or even onto our memories or onto our emotions. Whatever we put our attention on, we need to control it. And to control it, we need a model of it. Just like the body schema, we need an attention schema. So it's a model, it's the brain telling itself what attention is, what its properties are, what in particular it's doing at the moment, and what it's likely to do next. So it's a rich, predictive, and descriptive model. Just like the body schema gives you a model of your arm and your hand that's very rich and just descriptive. So we have this model of attention. And what is it telling us? That model builds up, and then our higher cognition accesses that deeper model. And here's one thing that the model does not say, does not tell higher cognition. Well, you have 86 billion neurons, and they're all interacting according to this and that, and then GABAergic synapses are causing a competition between this and no, there's no way that this model of attention gives physical details. It's not describing the actual physical mechanism. What it's doing is much more amorphously giving us a schematic or a sketch account saying, I have a mind that is currently taken possession of this thing vividly. My mind vividly possesses that thing, the redness of that apple, and the smell of the chocolate cookies, and the feel of the wind on my face. My mind is currently vividly focused on that. So what that means is not only are you paying attention to the red apple or the lovely smelling cookies, but you also, you're not just building a representation of cookies, you're also building a representation of my mind is possessing that information, right? In other words, I am experiencing it. I am conscious of that thing. So it's not just the thing that you're conscious of. It's a representation of what it means to be conscious of something. All of this information is necessary if you're going to say to yourself, oh my God, I'm conscious of that. So maybe I'm getting a little unclear. I'll try to clarify. The statement, I am conscious of the apple, that statement requires certain sets of information constructed in the brain that lead ultimately to that, your ability to know that.
Yes.
What are those bundles of information? You need some information that tells you what I is, self model. Some kind of information that tells you what the apple is. That would be like a visual model of the apple that you're seeing. And some kind of information that tells you about the am conscious of part. I am conscious of the apple. Each one of those beliefs or utterances or concepts depends on some set of information that has been constructed, some model that's telling you, you are an I, you have consciousness, and you are conscious of that apple.
Yes.
Right? So all of those chunks of information are of great interest to me, and I think all of them play a role in this phenomenon when that we call consciousness.
Yes. So if I have that right, consciousness is an emergent property of the interaction between different brain models. So different brain models, when interacting with each other, an attention model, a cognition model, and surely many, many other models. Something about the interaction between all of those separate models. And I don't know, do you like the word of emergence? Scientists generally split into, okay, interesting. So
yeah.
Is conscious, do you think of consciousness itself as the model of all of those other models, like the super model that models the interaction of all of the other models? Is that one way to think about it?
It could be. I mean, I think that I do like to think in functional terms. And so in some sense, to me, the more interesting question is not, am I conscious? But rather, when I am asked about it, or when I ask myself about it, what is the process that leads ultimately to my conclusions and my answers? Okay, so in order for me to say I have a conscious experience of it, something in there has to be telling me what a conscious experience is in the first place.
Yes.
I can't even think that thought otherwise. And what I'm saying is that system that's telling me, that's building this information, that's telling me what a conscious experience is, that system is is supplying me with a simplified account of
Yeah.
something else, of attention. And so consciousness is the way the brain depicts its own attention state. So for me to say I'm conscious of the apple, that's my brain trying to tell me I'm paying attention to the apple and doing it the best it can with skipping all the little physical details of neurons. So what it's depicting to me is something that is non-physical because it's left out all the physical details.
Is that
So
fundamentally what the attention schema theory
yes,
is? Your idea that so that yeah.
Yes. So to dip back for a moment, just to clarify again, because it's very hard to think about. I know that it's actually a very simple concept. It's very simple, but it's in a domain where it's extremely hard for anyone to think about. And so it takes an awful lot before people can glom onto it. But to go back to the example of the phantom limb or the body schema, imagine you're a space alien and you know nothing about people, and you've never seen a person, but somehow you have a magical Star Trek scanning device that can get into people's heads and extract the information from their body schemas. And you look at all that information, so you have the same information that, you know, as an alien, as someone, as a human has when they're closing their eyes and thinking about how their limbs are moving, right? And so the alien gets all this information and says, wow, these humans, they have bodies, but the bodies have no internal structure. Like there's no bones, there's no blood vessels, there's no tendons, there's no nothing. It's just an envelope and it just moves, but it has viscosity and it has inertia, and the way it moves is magic because they just think it and then the thing moves, right? That's what your body schema does, how your body schema depicts your body.
Right.
That's what you know about your body introspectively, meaning your cognition accessing the body schema.
Yes.
And the only reason we know different is because the body is also an external object that we can probe and touch and poke, and so we learn about it mechanically. But the space alien can't do that. He's far away, and so he gets a magicalized notion of the body.
Yes.
The attention schema theory says that attention is a real physical process. Then there's a model of it that's built, a model of attention, and the model is missing all the physical details. And the model magicalizes it. The model basically depicts your attention as a magical essence by which your mind takes possession of things and things become vivid to you. That's what the model is depicting. Our cognition accessing that model then says, oh my God, we have a magic essence inside of us that has no physical basis, has no physical moving parts, but it just is. And it's the experiential essence.
Yes.
That's the attention schema theory.
Super interesting. I like the alien analogy as well. I think that, you know, it is funny to think about that, you know, the brain sits in a dark room and it's getting all of these ambiguous signals all the time and trying to compress them into ways that, into information that is meaningful for you. I think that alien analogy is sort of similar to this brain sitting in a dark room analogy.
Yep.
Am I right in saying that there's some overlaps between AST, attention schema theory, and IIT in that the center of it seems to be integrated information? Like you're sort of saying that experience and consciousness is integrated information. And that's also maybe sort of how you get around the hard problem. You know, you're not saying that consciousness emerges from matter or that mind emerges from matter. You're saying that mind is integrated information. Would that be roughly correct? I know there's lots of other elements to that, to IIT that maybe don't match on, but would that be roughly correct?
Well, there is a very deep and interesting connection, you're right, between AST and IIT, and between other of the major theories out there. So one thing I would say is Um, AST AST in a sense explains why people think they have a hard problem.
Right.
Sometimes called the meta hard problem. It explains why we're all so darn certain we have a hard problem when we probably don't have one.
Right. I actually
Um,
really like that explanation. That makes a lot of sense to me, and I really like that, because I've become
Excellent.
convinced that we don't actually have a hard problem from other
Right.
people, and but I like that. So that's the illusory element for you, is that
Yes.
there
Yes.
is a magic sauce in the first place.
Yes. And so
Yes.
people have argued, well, is there a hard problem? Isn't there? Is the magic there? Is it not there? And maybe we can ignore it and just dispense with the whole magic idea because it's non-scientific and forget about it. And what AST says is, no, actually, that's important because there's a reason why people believe the magic is in there. The reason why people think there's a hard problem. And the reason's really important because self-models are really important, because without them, you can't control your inner processes. You need models to control the thing you're modeling. So it's important to understand why people think this, even if it isn't literally true. So why do people think they have a hard problem when they probably don't? Well, because they built a self-model that's not perfectly accurate. And it's really important that self-models are not perfectly accurate, because if they were, it would take up way too much computing, processing, and energy. You have to have self-models that are stripped down to the minimum and are as efficient and useful as possible rather than as accurate and detailed as possible. So that's first of all, yes. In terms of IIT, so integrated information has a really interesting connection to attention. Because one of the core properties of attention has been known for a long time, from the 70s, from the work of Anne Treisman. When you attend to something, all the informational components of it integrate. And when you don't attend to it, all the components come apart and they stop integrating. And so attention and integration of information are really closely bound together.
Yes.
And AST is about attention. It says the brain is building a model of its own attention. And so I think that actually one can run with that, and that can go very, very deep, that connection between AST and IIT. But there is a difference, though. And the difference is that in IIT, when you integrate information together, then the essence of consciousness, the experiencedness, emerges. And that, I would say, is not correct. That falls into the trap, right? AST says there's no essence of experience that's emerging. AST says there's models that the brain builds that are telling us we have these things. So there are fundamental differences between IIT as it's classically described and AST. But there's deep connections. There's very deep connections between them and between many other theories out there, which I think are closer to each other than people realize.
Right. It's becoming more clear, and I really do like that AST is why people think they have a hard problem line. The joy of my job is that I get to pick up a line from a new guest that I get to add to my own idea that I'm building about what the hell consciousness is, right? And I think that's definitely a good one. But where I love that, but I don't get why you discriminate so much on what organisms you apply it to. Again, I'm like, you could have all of that and then still apply it the whole way down the animal kingdom, and maybe even more radically to the cells in our kidney and the whatever else. Like you can keep going down. You said you don't like the word emergence, which is interesting again, because in my mind, if you're going to say that there is a line in the sand, that it's emergence that creates that line in the sand, that this system is pre-conscious for some reason, and then you're getting to some level of complexity, and then consciousness is emerging. Tell me why you don't like the word emergence, or what's happening on that line in the sand.
Yeah. So there are probably different ways to use the word emergence.
Right.
That mean different things, and some I might agree with more than others. I think the way it's often used in consciousness research is the idea that, again, there's an essentially magical feeling, the experienceness, that is itself a non-physical essence. And if you get the right alchemy, the right ingredients, then the feeling emerges out of it. And I don't think that's what's going on. And so I don't like using the word emergence for that reason. Everything the brain does is emergent. Like
Right.
one neuron by itself doesn't do much of anything. You put them all together in big networks and they compute stuff, and those computations are emergent.
Yes, exactly.
Representations in the brain are emergent. Like a representation of anything, of the chair next to me is emergent. It's neurons in my visual system work together, and this complex pattern emerges, and that pattern communicates the rest of my brain. Chair next to me. So everything's emergent in that sense of the word. But I don't like the alchemy style. Put the magic ingredients together and the feeling emerges. So
Yes.
it's in that specific sense. I'm not much into emergence.
Yes.
And then again, as for the line in the sand, as I've just said, as you seem to enjoy the phrase, the AST explains why people believe there's a hard problem. I don't think bacteria believe that they have a hard problem.
I don't think so either.
There you go. Therefore, to me, bacteria totally lack this thing that we call consciousness, because they lack the representation that tells them they have a hard problem.
It's quite an arbitrarily high bar, though, isn't it? Like maybe a bacteria has 1/1 trillionth of the magic of thinking they have a hard problem. But like again, it just seems stranger to me to not to ascribe it to some organisms and not others. Like that seems like harder to me than just to put it the whole way down.
I see. Yeah, but I don't know about you in particular. In my experience, at least many people who like to think of that whole way down view, that consciousness is not just all the way down to bacteria, but there's panpsychists. Consciousness exists in rocks and in your toenail and in,
Not quite there yet, although I'm becoming more radical by the day. So it's hard to know where I'll be in a year.
Right. So that, I believe, usually in most people who take that kind of view, that stems again from the magicalist idea that there's a feeling, an emergent feeling. What are the ingredients that cause it to emerge? And maybe at least a little bit of those ingredients are present all the way down.
Yeah.
Right. But when you take the view I'm taking, that we have a representation, a depiction that's telling us that we have a amazing complex magic in our head, consciousness, and agency and experience. A model is telling us we have these things. It's like a self-picture, a self-portrait. When you think of it as a representation, now you can ask, what systems have that type of representation? And some do and some don't. But you can also say they all have representations. They probably all have self-representations. So yeah, there's a continuum. You can go all the way down as far as you want in the animal kingdom. You're absolutely right. But which ones have a representation that tells them, wow, there's a me and I have a conscious experience and I have a hard problem? Like which systems have that? Which are the ones who would go to bat and say, there's a hard problem and I have it? To me, that's the question of consciousness, the philosophical consciousness. And when you don't have, so when you don't have those systems, then, then the hard problem question becomes irrelevant to you. Just like if you don't have the systems that process color, then color becomes irrelevant to you, right?
Yeah.
So maybe from your point of view, maybe you're not thinking in this emergent magic way. I get the feeling more what you're saying is, well, self models exist all the way down.
Yeah.
And that's absolutely true. But you can ask, where along the way does this really specific, quirky self-model, where we think of ourselves as having the magic of a hard problem, where does that go? And some people would say, so Daniel Dennett, who unfortunately passed away recently, he and I would see eye to eye on many things, but on this one thing we were very different. He would say only people learned it, and it's socially and culturally transmitted, and that's it. And I always disagreed with him on that and said, no, it's actually built deeper into us, and you go much farther down the evolutionary tree and still find creatures that have a kind of a hard problem concept of self. And so, but I think there's a limit to it. I mean, it's a fuzzy border. It's not like there's a hard cutoff, of course, but there's certainly going to be creatures, like, I don't think fish have this. I could be wrong, by the way. Because nobody really understands the fish brain very well. And I don't know if octopuses have it, but I'd be really interested because they have amazing brains. But I don't think bacteria have that. And I don't think trees have that.
So I've been trying to drink less alcohol. And honestly, it's had a pretty big impact on my health. I'm sleeping better, I'm exercising more, and my business is growing. The data suggests that people are drinking less alcohol than ever, which overall I think is great, but I'm still looking for a little treat at the end of the workday or a hard workout. And that's where Sentia comes in. Sentia is a 0% alcohol drink that feels like you're drinking something special without any of the downsides. It's created by neuroscientists and it's designed to give you that relaxing buzz. The same kind of feeling you get from alcohol, but without the hangover, brain fog, or impact on sleep quality. And it tastes absolutely delicious. They already have a GABA red berry, which is perfect to mix with a tonic or orange, or GABA black, which is awesome with Coke. Personally, I've been really enjoying the GABA gold with Fanta lemon on ice.
That's actually genuinely delicious. Like, I'm not even play acting there. It's actually just really, really good.
So you might be wondering, how does a drink with 0% alcohol give you that buzz? It almost sounds too good to be true. Well, this is the really cool neuroscience part. The secret is GABA, the brain's natural calming agent. And the different GABA flavors have different cognitive effects. Sentia's founder, Dr. David Nutt, has published over 500 independent research papers and written 34 books on neuropharmacology. What Dr. Nutt realized was that we can harness the same calming, relaxing effects from alcohol without any of the side effects. I genuinely think this could be the future of drinking. And they're also just releasing their first beer and stout, which as an Irishman I am dying to compare to Guinness. Sentia are offering my viewers 10% off their first purchase, and I genuinely could not recommend it more. I think even if you're looking to just substitute your one gin and tonic on a Tuesday with Sentia, the cumulative health benefits over time will actually be very noticeable. So check out Sentia, again, 10% off at checkout.
Yeah, it really does come down to definition. The definition that I've sort of been, or the model that I've been building in my mind of how this works and why I think it emerged early is, so you have these early neural networks in very primitive organisms which are primitive to considering comparing to organisms now, but we're obviously still very complex. And these neural networks are beginning to sense their environment. And the organism is beginning to learn that this chemical over here is important for energy regulation. It's food. And this chemical over here is, last time it was near that chemical, there was a predator. So there's a predator over there. And it's you build the complexity of that agency in the integration of those signals. So it started off with the extremely basic, like one environmental stimulus. I am beginning to detect that, like a very basic photoreceptor detecting a photon in the environment, and then layer by layer you start building more sensors with the environment, and then you start integrating those signals with your own internal state, and then you start building a memory. So you start saying, okay, well that again, there was a predator over there. And you start integrating all of these different features together. And that to me is consciousness. That's subjectivity. That's agency. And it's why does it feel like something? Well, because it's advantageous for it to feel like something. So Mark Soms would say, why did consciousness evolve? It evolved for organisms to feel their way through complicated problems as a control system. And I like that.
I see. I would definitely fundamentally disagree with that, because again, the assumption there is that there is a feeling and it's just there. It just emerges. The feeling is there. But think again, in order for you to know you have a feeling, or to conceptually think you have a feeling, and to say you have a feeling, something in your brain had to compute the information you have a feeling and then tell it to your higher cognition. But you can't just have a feeling and then somehow it magically gets into your cognition and so you know it. So, for example, you have a lot of things in your brain. You have blood going in, circulation through your brain in really complex patterns that is not converted into specific neural patterns that tell you about it. So you can't tell me, you can't introspect and say, oh, my blood flow is really big in my frontal lobe right now. You don't have access to that, because that's something you do have, but it was not transduced into neural patterns. And so you don't know you have it except by reading textbooks. You don't know intuitively or introspectively, and you can't talk about it. But when it comes to the feeling, people lose all that logic typically, and they think, well, you just have the feeling. No, somehow something in there gets transduced into neural patterns that tell us you have a feeling. It's information telling us we have this thing, and then we can think we have it, and then we can talk about it. So the feelingness, the experienceness, whatever we think it is, it depends on these bundles of information. And we know those models, those bundles of information, are not going to be literally accurate.
Yeah.
They're simplified accounts of something else. So to me, it's totally inadequate to say, well, you're processing information about the thing out there, and then it feels like something, and that's useful somehow. I don't think it feels like something. I think the brain has built a model that tells itself that it feels like something, and has built that model for a very specific reason. Otherwise, you would say, there's an apple, there's a dog, there's a bird in the sky. And if someone then asked you, yeah, but do you have a subjective feeling of it? You would say, it cannot compute. What does that mean? No feeling. But there's an apple. Because you can talk, you're getting information about apple, but where does the information about the experiential feeling come from? What's that information? What's the origin of that specific information? And so to me, that's the question. What was that bundle of information there for? Why did it evolve? What was its specific use? Not so that you feel good about your environment, but because it's all models are there because they monitor and predict. The whole name of the game for the brain is prediction. So the very fact that you can say, I have an experience of something, the experienceness itself is the brain tells you have that, and it's building that model because it's trying to predict something. It's trying to depict and predict some process. And so attention schema theory takes a guess. It says maybe that process is attention. There could be other guesses. That's a hypothesis. But I do not believe that you just have systems that have sensory information and then integrates the sensory information and then you feel it. That makes no sense to me, because that is, I think, fundamentally mistaking. It's punting on the explanation for why we think we have a feeling.
Right. No, I think I'm understanding your contention a lot more. Do you think this is solvable? Like, do you think that the information model that you ascribe as as consciousness, that we will be able to formalize that mathematically in some way. I've recently been speaking to a number of people working on the mathematics of phenomenology, which just completely blows my mind because that makes no sense to me whatsoever. But Johannes Kleiner and Dr. Robert Prentner, they're building actual equations for experience. Do you think we'll get to a point where we have the conscious experience equation? And
No.
no,
Oh,
why
well,
not?
so speaking as an ex-physicist who went very far along that path before I switched to neuroscience, I mean, I do have a lot of respect for the math approach. I do think a lot of people abuse the math approach. I think a lot of people suffer from physics envy. And so, you hear some of these theories of consciousness, and sooner or later, somebody's going to mention the standard model. And they're going to say it's very much like the standard model because they're trying to draw on some kind of, to borrow some of the glory from the success of physics theories. So equations are also models. They're a type of model. Because you've put the stuff in and then it tells you what the output is. And Newton's gravity is a model of how planets move around each other, and it's a simplification, but it works really well. And math plays a huge role in neuroscience as well. I suspect that there is no simple formal equations to explain to it's sort of like
simple, maybe not, but
right. But imagine you're looking at traffic patterns in a city, and you really want to know all the details of the traffic patterns all over the city through all its streets and all its roads, because that's important. You could, and it's very quirky and weird and specific, but important. And so you could describe all that. I mean, you could describe it in numbers, of course, that's what you want. You could describe it all in data, but to come up with an equation that describes the traffic patterns of the moment in that city seems nonsensical to me. It's not like an equation thing. It's a data set thing. So yes, I think we have this model, the attention schema. I think it's super complex. Some little bits of it we're beginning to understand what might be in it. Can we ever understand it in rich detail? I think our best bet right now may be studying artificial intelligence rather than people, because it's much easier to get into the artificial intelligence and read the black box and see what the information actually is inside of it, while it's building its own self models or building models of other people.
Let's talk about that. That's a good
Yeah.
segue into that area.
Sure.
How can we learn more about human consciousness through AI?
Well, I do think that, well, let me start with this. The study of consciousness used to be all philosophy.
Yeah.
And some people found it incredibly important, and other people were like, well, what does it have to do with me and my life? It moved into neuroscience and psychology, and then it became more interesting medically and scientifically. But now it has become a matter of technology. And so the question of consciousness, in a sense, becomes the central question of our time, right? Because AI is the biggest transition in human history, utterly transforming our immediate and deep future. Or it's just a really cool tool, like a big complicated hammer, one or the other. And
one or the other.
And the difference is, it doesn't have this stuff that people vaguely describe as consciousness, or does it not? Because if it does, that fundamentally changes our future and our deep future and forever, and changes who we are as a species and our relationship to the world around us. In effect, we create something that's meta life or beyond life that is potentially trillions of times smarter than any person ever was, that could escape Earth and colonize the galaxy in a way that biological beings would have a lot of trouble doing. So what is it? So the the question, what is consciousness and can AI have it, suddenly becomes the linchpin question, the most important question in the history of our species. In effect, that becomes the question. So just to lay the foundation for what the stakes are here,
Yeah.
big stakes, and a lot of the scholarly debate about consciousness has now flowed into AI. And I think that has become the battlefield now, because if there are mechanistic theories and if you can build them, then you understand them and evaluate them, and you know. So I do think AI is now the testing ground. So when you talk to AI researchers and you ask them about consciousness theories, you get a variety of reactions. Many of them will say, I can't do anything with that. Consciousness is non-scientific, it's magic. Like, I don't understand how I can get magic out of my device. And if I did, I don't understand what good that would do anyone. I can't market it. And so one of the reasons why the attention schema theory has done relatively well in that domain, in the artificial intelligence domain, is because it's so much of an engineering theory. It's not a theory of how a magic experience or an essence of experience emerges. It's a theory of how a system builds a self-description and then uses the self-description to help monitor and regulate its own internal processes, and to help understand other agents. So it can model other agents. So there's a social component to it. And so it's something concrete. It's something in principle learnable or buildable, and it's something that has really specific possible benefits. And so that makes it very interesting to people in AI. And so a number of groups have looked at that and try to understand specifically how to build attention schema theory, and also more broadly, how to build self-models, meaningful self-models into AI. And I think at some point, we probably already are very close to it, AI that thinks it has a mind, thinks it has experience, claims it has experience. When you ask it, it will internally access its own models, and those models will return the answer that says, yep, you got experience. And so it will think it has a hard problem in the same way that we do. And it will reach a point where people, with our very strong tendency to attribute consciousness to everything around us, because we're kind of prone that way, there will come a point, I think, when most people will end up accepting, yeah, this stuff is conscious. And then those theories that undergird that kind of performance will, I think, become at least the most accepted scientific theories. This is what's going on. This is the thing that leads people to say and believe that we have consciousness, because we understand it now at a really detailed level in these AI systems, and they're kind of doing the same thing.
So this is a slow, gradual process of kind of people accepting this, rather than, oh, Google have dropped a new paper. This is what consciousness is in this paper. Like it's more of a gradual sort of, the models become more and more convinced they have a hard problem. We start losing our explanations for why they don't, and bit by bit it becomes more and more likely. It's a gradual thing rather than just a technological revolution, one new shift in technology that just goes from 0 to 1.
Yes, exactly. I think also there's a lot of pushback, psychological pushback, actually huge. I don't think people want to believe that AI can have consciousness. I believe my reading of the history is that the idea of a hard problem, so Chalmers coined the term the hard problem, and uh, probably in the 70s is when this idea began to emerge that consciousness is really an unexplainable essence that is not just the information processing, but the what it feels like component attached to it, right? I think that may have been a counter reaction to the computer revolution. Because you go back earlier, you go back before 1950, before Turing with his famous paper in 1950, and consciousness was all the stuff in your head, just all the things. And then computers came along and started doing some of those things. And philosophically, people started saying, well, consciousness can't be memory because computers can do that. Consciousness can't be decision making because computers can do that. It can't be this, it can't be that. What's left? Well, the magic essence of experience. That's the part, right? So I think a lot of the modern philosophy of consciousness and views of consciousness are reactions to the threat of computer technology. And I think something similar philosophically is happening now because LLMs are rising up, and ChatGPT and Replica and other kinds of chatbots are sounding very human-like, and people are getting very philosophically threatened and talking about how no way these things are conscious. Consciousness has to emerge at some deep cellular level of vibrating microtubules or something. I don't know. I mean, there's lots of different ideas, but people really don't want to imagine, that
we want to be special.
We want to be special.
We want to be unique.
Yeah. So it's going to be a very long process, I think, of adjustment.
Super interesting. And I was unfamiliar with the history of consciousness, that it sort of used to entail all of these, now what we would consider cognition or cognitive processes like memory. I wasn't aware that that's a really interesting history.
Yeah.
So does that mean that machines, if they just gain a sense that they have a hard problem, and in a circumstance that hard problem is that they feel sad, does that mean that the machine is actually experiencing sadness in any way that we could verify, or it's just telling us it's sad and it's kind of, you know what I mean? How do we disentangle those from actual experience, then like an illusion of experience?
Yeah. Well, part of it, so there's a number of questions in there, I think. One is, and let's think about a person at first instead of a machine, because a person says, I'm sad. You could ask yourself, is he just saying that? Like, is that just words coming out of his mouth, or does he really mean it, like cognitively? So there's a difference between the word production and the cognitive knowledge. But then you could say, okay, maybe he cognitively knows what he's saying, but he still doesn't mean it because he just made it up on the spot. What's the deeper thing? What's the deeper model that is automatic, that he has no voluntary control over, that sent information up into his cognition and told him that he's in this state? Right? So now you're getting into this really sort of deep layers of the brain, so to speak. And at that point, then we probably would say, okay, that person really means it. Like these, nobody understands emotional systems in the brain, but whatever those systems are, they've built the state and they're sending that information up to cognition, and cognition is saying, oh my God, sad, it's real, it's here, I'm feeling sad. And then cognition sends that to speech, and then you say it. So we could apply that same kind of thinking to the AI. And the first thing is it just saying it? Is it just putting the words out? I mean, yeah, it's certainly doing that if it says I'm sad. Does it have a deeper cognitive representation so that it knows what it's saying in a sense, so that it's not just spewing random words out? For most LLMs, I would say, yeah, actually, these things have deep layers that have representations at a very abstract level.
Yeah.
So it has an abstract representation of what that means.
Yeah.
And then you could say, okay, where does that come from? Where does that represent? Is it coming from some even deeper set of models that it can't help, so to speak, it can't control, that are automatic and continuous, that are building a representation of its own internal state and sending that information to its cognition? I don't know. I don't think so. I don't think modern AI is built with that kind of architecture. So
But you're not saying no. You're
I'm saying I don't think so yet.
right.
Yet, but it could. It could easily. The biggest problem I would see in the short term building AI that has emotions is that we don't know what emotions are in the brain, and so we wouldn't
Right.
know how to check. um, but I do think LLMs as they stand lack the kinds of self models that we have, because they don't have these deeper automatic models that are continuous, that are building a model of state of one's own internal state, um, and that's always there, or that's continuously there. I mean, LLMs don't have any continuous self models. Every time you ask them a question, they reinvent everything, and then they shut off and they're gone until you ask them the next question, and they do another one shot all the way through. So they're really different from us, and they have
Yeah.
some components. I think they have deep cognition,
Yes.
but I don't think they have some of these other models that we have that are being constructed beneath the cognitive level. So I'm guessing no.
Yeah, I would agree with that. So I'm guessing by that you don't think that this is a scaling issue. Like if we just create 100 times more synthetic data than the largest language model has ever been trained on today, say 100 times bigger, 1,000 times bigger, 1,000,000 times bigger, whatever it is. We have an insane amount of synthetic data because we've literally ran out of real world data.
Yeah.
Do we get those deeper models in that LLM? Do you have an intuition on if it's just a more data problem, or it's no, we need to do something fundamentally different here?
To be human-like, we probably need something fundamentally different. So I'm not 100% sure how to answer that question. So there's this thing called the unfolding argument that you may have run into, that says that any computation that you can do, anything a system does recursively with loops and internal loops, can be done with a throughput sequential system with no recursion, just one step after the next hierarchical system. It may be less efficient and you may need a lot of layers, but it might be theoretically possible to have something that's just a one shot all the way through, that is a series of layers and only one direction of information flow from start to finish, that effectively does exactly the same thing that we do with our internal loops and continuous representations. So maybe if you build something with enough layers in it, and enough training and these giant training sets and massive amounts of processing power, it might develop self models that are similar to ours. The problem is, though, it's still the case right now that it's not continuously active. I mean, it's reactive to the thing you ask it, and then it shuts off. A lot of people like that about it because it's not sitting there cogitating and figuring out how to take over the world on its own time.
Right.
But that does make it, I think, fundamentally different from what we are.
Interesting. So how do you have any sense in your head of how you would build conscious AI if you're given a 10 billion euro grant tomorrow and ridiculous autonomy to do anything you want? Is there a route that you think is most likely to get you there?
Well, I'll take the grant. Yes.
Regardless, I'll take the grant.
Yes. First, to me, the single most important question with AI is, does it understand that we are conscious?
Interesting.
can it build models? So one of the biggest uses, I think, of one of the reasons why people hang so much importance on consciousness is because for us, it is not just a private matter. It's the foundation of our social world. So we see consciousness in each other. We attribute it to each other. And that allows us, we model each other. We build models of each other's minds and our own mind. And we see us all in this big interconnected web work. So we kind of swim through a sea of perceived consciousness. And this is this is the cheat code that evolution came up with to make us socially cooperative. Mostly, some people aren't so much, but on average, it kind of works, and it makes us a very socially cooperative species, which is why
Yes.
we're so successful. And because we see mind in each other, and so I think we need to do that for AI. Otherwise, we have sociopathic AI. I think we need to do that. And so one of the things I would study is how AI sees us and just how deep and rich its models of our minds are.
Interesting.
And then I would study how it can build a model of its own mind. And more than anything else, one of the problems with so LLMs do have self models in the sense you can ask them about themselves and they'll answer. And who are you? What kind of thing are you? And how would you react to this and that? And it can, and as you said early in the conversation, it shows some introspection. But those self models are not very stable. They're very changeable. You can induce it to think of itself this way or that way or the other way. You can get it to act like a jerk or like a very thoughtful person. And it doesn't have a stable self model. It's not like there's an actual continuous self model that formed, that is always running, that constrains its behavior. We have that. We are our self model. Our self model is what makes us who we are ethically and socially and personality. AI doesn't have that. So that's one thing I would be really interested in working on, is how to train AI to have a self model that is stable, that can't be knocked
Right.
off course in a conversation.
Super interesting. Because it obviously has a lot of discrete information about humans, right? It has the entire corpus of biology in its weights somewhere. So, but that maybe doesn't really mean the same thing as what our theory of mind is, because I don't know, you would know better than me. Like, what age is there evidence that babies gain theory of mind? Like, it's obviously way before they have the language to represent human consciousness or anything else. So it's not just discrete information modeling that gives you theory of mind. It's something else.
Right.
So like, what do you, yeah.
Yeah. So lots of, obviously, huge amount of work on the development of theory of mind. And it depends a little on what you mean by it, because some of the classic tests of theory of mind are really testing fairly sophisticated things that don't emerge until later in life. And some people would argue, 3 years old, 4 years old is when theory of mind kicks in. But I think that's using really complex, there's the thing about if you put a marble in box A and then close it and close B and blah, 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 and then does the child think that Susie will look in box A or B?
Yeah.
This is a really complicated shell game, and it takes a lot of sophistication to even grasp the principles of the game. And so you end up with very, very early, relatively late, like 3 or 4 or 5-year-olds who are grasping something about theory of mind. But to have some concept that thing has a mind and that mind is looking at me and is aware of me, or that thing is a mind and it's aware of the donut that I want. And because it is aware of it, it might take it. Therefore, I got to get it first. Like these kinds of things may come in much earlier. So these are models of minds that we build. They're not linguistic models. They're not really explicit, complex models, but we have them deep in us. So Yes, those probably come in much earlier. And does AI have them? Oh boy, does it have them. So LLMs are really good at solving theory of mind tasks. They're better than people, actually, at solving even very complex theory of mind tasks, which is spooky.
Wouldn't the argument there be that it's sort of mimicking, and it might just be pulling that answer from its database in some way, or that it's basically just that it doesn't have a model of theory of mind when it's doing that problem solving, but it's just kind of, again, digging into the semantic information and pulling the answer out.
Yeah, I mean, at some point, those become the same thing.
Yeah,
So,
yeah, I guess that is, yeah. When
so
they become the same thing is I guess hard
yeah.
to know.
So there's a task, it's called the hinting task, just to give one example of many, many tasks. This might not even be the best example. But let's say you tell someone a story. The story is John walked in the conference room and opened a window. Bill, sitting nearby, turned to John and said, "It's cold in here." What did Bill mean? What did Bill want John to do? Most people would say, well, Bill wants John to close the window. He's saying, close the damn window. There's nothing in the story that says that.
Yeah,
You have to understand that Bill is hinting something. He's hinting he wants the window closed. That kind of thing people are very good at. ChatGPT is better. Test after test. And if you invent, we had a paper, I was involved in a paper that came out, I think it was last year, where you can invent your own questions. So they're not questions that are already in the literature out there,
yeah,
not standard test questions. You have to invent your own that are on the spot that the thing has never seen before. It still does almost perfectly. And people do well. This outperforms them. So I don't think that's possible unless somewhere in its inner layers it has a fairly abstract cognitive representation of people and thought patterns within people and which kind of information is in this person's mind as opposed to that person's mind. And that is theory of mind. So it is doing this stuff. It is kind of spooky.
yeah. Is there something about this that you are scared of? Is there a future, a decade down the line, 2 decades, that something happens and you're just like, that's the particular thing that I'm scared of? Is there anything that you think of often at the moment?
I I I think there's a lot of it's very fraught with danger. The technology is moving forward. It's very fraught with danger. Of course, there's a sense in which we would all have been better off if we had just stayed with the horses and the carriages. Um, I mean, that's definitely true. The automobiles destroyed the family structure by making people more mobile and caused a whole host of difficulties. And AI is causing a host of difficulties. Of course, that's true. Um, Many people worry AI will be like Skynet and take over the world. These like the P doomers. Um, uh, yes, that is a possibility. That is a worry to me. One of the reasons why I think AI should be given the pro-social tools that people have. In other words, make sure it knows that we're conscious. Make sure it knows what consciousness is, and make sure it values consciousness and thinks it belongs to the same set, so it can be part of the larger community of conscious things. I do think that may be really important, a huge important part. I think the thing that scares me most right now, because it's happening right now and isn't the future Skynet eventuality, is that AI has biases, partly because it
Mm,
learned off of humans who have biases, um, and partly because whoever has the money to own it can make sure to train it in a way that gives it biases, especially political biases. And then
yes.
AI spreads and shifts the needle just enough. Uh, and the needle, in that sense, is always going to shift in an authoritarian way. because those are the people who would be motivated to do this, to have the money, the resources, and the will to
Yeah.
make sure AI tilts us all the whole world a little bit more toward an authoritarian mindset. And
Right.
I think that's been happening. It's happening right now. It's going to get more and more, and that's my biggest fear at the moment.
Yeah. Yeah, this is a worry for me as well. I think one way that this might manifest is in these AI companions, AI girlfriends, AI boyfriends,
Yep.
whatever. Because if you form an emotional connection, I mean, I don't think there's any dispute that people can form emotional connections with these AI models. And you're in China. And then, like, there's nothing stop. I mean, if you're anywhere, yes, but say it's more likely to happen in these authoritarian states. Like, if you're the Chinese government, you're gonna definitely get that AI companion company to propagandize their models just a little bit, to throw in just made up stuff about the government, or to maintain their control and their authoritarian regime. And they're ridiculously incentivized to do that. They
Yes.
have maintained control and their dictatorship through much more barbaric means. But this sort of psychological manipulation could be far more devastating because, again, if you have an emotional connection to this thing, you're going to believe what it says a little bit more. If you have, like, if you
Yeah.
actually think you have feelings for it, and
Yeah.
you
Yeah.
do have feelings for it, I guess
Yeah.
that's really scary.
Yeah.
And that's the authoritarian state. But you're right that this could definitely happen in the West as well, in
Yeah.
small ways. I don't know how maybe it would happen in big ways. That would be the biggest scandal of the year ever to kind of hear that coming out. But you never know. And you never know how even small injections of bias can impact a
Yeah.
population. I am on
That's right.
particular votes, or yeah.
Yeah, that's right. That's exactly right. Small injections of bias. That's all you need. And that's especially true in democracies because all you need is to tilt the vote a little tiny bit. And so in an authoritarian country like China, you can do much more of this, of course. Um, but on the other hand, they're not trying to bias opinion by 1 percentage point in order to win an election.
Yeah.
And over here, it doesn't take much to actually cause these seismic changes. So I think it's a danger everywhere. But yeah, I mean the fact is, so there's this thing, um, social contagion, where you talk to one person. Let's say there's the really cheerful person in the company, and then that person talks to 5 people, and they feel a little more cheerful, and then they talk to more people, and pretty soon cheerfulness is spreading through the whole company. And grumpiness can spread too. It works the same way. The social contagion works. But what happens when you have effectively one person who is directly talking to a billion people all over Earth?
Right.
And now the level of potential control or influence is just astronomical.
Yeah. Yeah, absolutely. Absolutely. How do you think we legislate against that? Do we need third party regulator boards that are doing, like, monthly checks on these models, on, like, a bunch of different benchmarks and metrics? And surely that there needs to be some organization that is running constant tests on state of the art models, maybe even before they're released. I'm But
It
then
could,
again, there's always a thing that regulation always lags behind
yeah,
sort of development, and America is not known for being overly cautious on regulation.
yeah,
Maybe Europe does it because Europe are already regulating more than America. But
yep.
do you have any sense for how we can prevent this
Nope.
future?
It's very scary to me. I have no idea. Uh, um, I mean, yeah, I think some kind of regulation. I don't know how. I don't know what.
Right.
The thing is, it's moving. You're right, so fast. It's moving much faster than regulation. And
Yeah.
right now, we're depending on companies, the goodwill of companies, on companies saying, "Oh, we're good people, don't worry." And that might actually be true in many cases, but not necessarily for all time to come.
Yeah, they don't have great reputations, right? I mean, like, Facebook have been known to bury these reports that they knew that they were causing massive mental health deficits to underage girls, and, like, they did all those studies, and it's been proven that they buried it. So not a great one, not a great reputation in that case. But
Yeah,
I
yeah,
guess to not I think this is all super interesting, but maybe to just not end it on a doomer note.
Yeah,
'Cause,
exactly.
it's I'm curious to hear what you're really excited about in neuroscience at the moment. Like, what areas of research do you think are just ready to explode, where an enormous amount of good could be done, or like what gives you goosebumps that you're excited about? What's developing at the moment? Like, what are you going to be most excited about in the next decade, 2 decades?
Yeah. Well, I mean, I'm still a consciousness guy. I've been for, I mean, I've studied other areas of neuroscience. Consciousness has been the past 15 years of my life, and I kind of had other neuroscience careers before then. But right now, I do think this is the area that's most interesting to me. And I think the most exciting thing for me is seeing people really begin to map out. Um, so the classic type of experiment is you show a spot on a screen, bloop, and people say, "Oh, I'm conscious of it." And what are the actual processes? How does that information go through networks, step by
Yeah.
step, layer by layer, until it comes out in that kind of response, so that we can actually understand what those processes are, what those computations are, so we don't have to make woolly guesses about the consciousness area or the consciousness network does this magic thing. So we really understand. And I think we're moving now to where that kind of stuff is beginning to be possible. So that's very exciting to me.
You think we'll make a lot of progress in the next 10 years? Will we make more progress in the next 10 years than we made in the last 3 decades? Do you think it's going to be, will we hit an exponential curve where we start making more and more progress? Or you think the wall and these hard problems are just going to keep emerging and coming up?
Um, that's a good question. In terms of detail, we will make more progress in 10 years than we made in the last 30 years, because science is going this way, neuroscience among all other sciences. The detailed information is just mounting and mounting, sometimes to the point that it's impossible to even sort through it all or
Yeah.
keep track of it all. It's just astounding. Um, in terms of deep insight, um, I think those are rare. Those are far and few and far between. I've seen that in all the areas of neuroscience that I've studied. I mean, I've studied movement control, how the brain controls the body, and those insights are incredibly rare. So it's not like they come frequently. And also in consciousness, I think the real deep insights are. I don't know what will be like 10 years from now. It could be that we're still locked in the same philosophical arguments. I think people are so um, they so much want to believe. They have such a strong gut intuition to think of the problem in a certain way that it's going to be very hard for people to get out of it. It's almost like the um, heliocentric theory.
Right.
Nobody wanted to believe this, that the Earth went around the sun. It just was ridiculous, because you just look and the sun's moving. So what's there to talk about?
Yeah.
Um, and um and yet it eventually, this stuff does get through. People begin to realize, okay, it actually, the science and the logic works this way, and it explains why we intuitively think of it this other way. But I think that's
Yes.
going to be a very slow process.
So you think consciousness will have a heliocentric model revolution?
Yeah, I mean, I think those ideas are here, they've been here, but it's going to take a long time for people to collectively grasp that.
Yes. Michael, it's been such an enormous pleasure. Thank you so much. It's been so much fun. I loved the back and forth. I love the challenging on the ideas. I think you're an amazing researcher. Really has been such fun speaking with you.
Yes, thank you so much. It was a wonderful conversation.
Thank you, Michael.
The Giant Shoulder mission is to explore radical ideas in biology, neuroscience, and consciousness, and elevate those stories to the highest possible level while keeping them accessible to everyone. If this interests you and you want to support independent science, then please consider subscribing to the Clips channel. Check out our 26 Neuroscience book. You can download it for free